Good morning, dear children. In your chemistry class today, you will learn about acids preparation of acids. Someone asked me the other day, why don't you take an online class? Well, here I am. Preparation of acids. We have already learned about what are acids and what are the fundamental properties of nature. We have learned about it already. So today, this is second class on acids, preparation of acids. Let's go. Acids are prepared in several ways. Acids are prepared in several ways. Easiest is to combine hydrogen with another nonmetal under suitable conditions. Hydrogen and another nonmetal under suitable conditions. Hydrogen in one jar. Hydrogen is there in one jar. And another nonmetal, suitable nonmetal, say chlorine. Hydrogen and chlorine. In one jar you keep chlorine, hydrogen being light, keep it on the upper one. Chlorine is slightly heavy, so it's lower. And mouth to mouth, that you keep it in diffuse sunlight, mouth to mouth. Hydrogen is this, chlorine is this, mouth to mouth. You keep it in diffuse sunlight, you'll hear a small explosion. You'll hear a small explosion when hydrogen and chlorine are combined to give hydrogen chloride. The reaction, chemical reaction is hydrogen, I write here H2, and chlorine, Cl2, combine to give 2HCl, hydrogen chloride. Hydrogen chloride dissolved in water is hydrochloric acid. So this is the simplest way. Hydrogen and chlorine combine to give hydrogen chloride. Hydrogen chloride is a gas. This gas can be dissolved in water when you get hydrochloric acid. This is known as direct combination. This is the first method. Direct combination. Direct combination. Direct combination is also called by another name synthesis. Synthesis. Direct combination or synthesis. Hydrogen and chlorine combined directly. This reaction takes place in diffuse sunlight. I told you this apparatus you keep in diffuse sunlight, you hear a small explosion, the two combine, hydrogen chloride form. This is one method, and here is selected chlorine. And I selected fluorine F2. Fluorine and hydrogen, they combine, they don't need a sunlight also. They combine even in the dark and at very low temperatures to form 2HF. And HF is hydrogen fluoride or hydrofluoric acid. HF is hydrogen fluoride. Hydrogen fluoride. Fluoride spelling, be careful. FLUORID. Hydrogen fluoride or hydrofluoric acid. The reaction takes place even in the dark and at very low temperatures with explosive violence. It takes place with explosive violence. Great affinity, hydrogen and hydrogen or fluorine has very great affinity for hydrogen. And because of the great affinity, hydrogen chloride is formed even in the dark and at very low temperatures. And hydrofluoric acid in water is hydrogen fluoride in water is hydrofluoric acid. Reaction is very fast. Here, diffuse sunlight at least is required. Similarly, hydrogen can combine with another hydrogen, bromine, and produce hydrogen bromide. Similar. All these are similar. Another reaction is hydrogen can combine with sulfur, and produce hydrogen sulfide. This is also a light as a weak acid. hydrogen combines with sulfur. What is done is sulfur is a yellow substance, Yellow can be powdered and it is heated and boiled. Sulfur can be boiled, hydrogen can be passed through boiling sulfur when you get hydrogen sulfide. Hydrogen sulfide is a very weak acid. It's a very weak acid, hydrogen sulfide. So these are all direct combination of the elements. One of the elements being hydrogen. Without hydrogen, there is no acid. Without hydrogen, there is no acid. So one of the element has to be hydrogen, and other can be some other non-metal suitable. So these are the examples of direct combination of elements or synthesis of elements resulting in formation of acids. These are all acids. Now these acids are usually called hydracids. They contain hydrogen. So we write hydracids. So only hydracids can be combined, can be prepared in this manner. Only hydracids can be prepared in this manner. Are you clear? I hope you understood. This is called direct combination or synthesis. Two elements combine, one of them necessarily hydrogen, and combines. Some conditions are to be satisfied. Sometimes it will take between low temperatures even, and then diffuse sunlight is required. Suppose boiling is required. So accordingly you can get acids. So this is the first method of preparing acids. Are you clear? Are you clear? Now the second method to prepare acids. That is to react acid anhydrides react acid anhydrides with water react acid anhydrides with water. Now if you are clear about this, I'll rub it off so that I can show the rest clearly. The first one was direct synthesis, done. Second, reacting. You can write better by reacting acid anhydrides with water. Acid anhydrides with water. By reacting acid anhydrides. Acid anhydrides are also called acidic oxides. Another name given to acid anhydrides is acidic oxide. Or it can be called also non-metallic oxides. So by reacting non-metallic oxides with water, you get acids. How? Let's take an example. Now there's a gas called carbon dioxide. You know this gas very well. Carbon dioxide is required by plants in photosynthesis. You must have done. So carbon dioxide gas. You dissolve carbon dioxide in water or react carbon dioxide in water. The resulting product is H2CO3. This is called carbonic acid. And carbonic acid is the prime constituents of all your fizzy drinks. Fizzy, F-I-Z-Z-Y. Fizzy drinks. Soda, lemonade, orange squash, or the fizzy part is from bicarbonic acid. So it's not poisonous, we take it in. But carbonic acid is prepared by dissolving carbon dioxide in water or reacting carbon dioxide in water, producing carbonic acid. It's a weak acid. It's a very weak acid. Carbonic acid is a very weak acid. It's a very weak acid. Another one, example, sulfur dioxide. You can make sulfur dioxide react with water. It produces H2SO3. This is called sulfurous acid. Sulfurous acid. Sulfurous acid. H2SO3 is sulfurous, not sulfuric. Sulfurous acid. H2SO3. H2SO4 is sulfuric acid. This is sulfurous acid. H2SO4. This is prepared by reacting sulfur dioxide gas. This gas is called sulfur dioxide. Sulfur dioxide. So sulfur dioxide reacts with water, produces sulfurous acid. Sulfurous acid again is a somewhat a weak acid. It's a weak acid. Another, we can take nitrogen pentoxide, N2O5. Nitrogen pentoxide. You may ask me some, why not nitrogen dioxide? I'll come to that later. At present, let us do this. Nitrogen pentoxide it is called. 5 oxygen atoms. Pentoxide. Nitrogen pentoxide. Nitrogen pentoxide. This reacts with water. It produces nitrogen pentoxide reacts with water, produces nitric acid or HNO3. Nitric acid. 2HNO3. Equation balancing we have learned already, I'm sure. So N2O5 plus H2O gives 2HNO3. This is nitric acid. Nitric acid. HNO3. Here nitrogen pentoxide is an acidic oxide. Acidic oxide of nitrogen. N2O5 plus H2O. So too is phosphorus pentoxide. Phosphorus pentoxide, P2O5 or phosphorus pentoxide. Phosphorus spelling, note the spelling PHORUS, not ROUS. Phosphorus pentoxide, and again spelling pentoxide. POXide, some children write TOH, but TAO. No, wrong. Not TAO, TOXide. Phosphorus pentoxide dissolved in water with H2O gives H3PO4 phosphoric acid. H3PO4 is phosphoric acid. Phosphoric acid. Phosphoric acid. H3PO4. Does it balance? You can easily balance it. There is 2P2O5, so it's very clear there should be 2 H3PO4 at least. Since there are 2P2O5, it's at least 2 H3PO4, 2P is accounted for. There are 8 atoms of oxygen, 4 to the 8. You get 8 atoms of oxygen. How do you get 8 atoms? It will be 4 H2O. So 8 atoms of oxygen are there. 8 atoms, sorry. 4 to the 8, that's right. So 5 plus 2, 8. 5 plus 2, 8. 5 plus 2, 5. Here 5 as oxygen atoms. No, not yet. You have to balance it properly. With this 3 H2O, H3, 2 H3PO4, 6 hydrogen atoms are accounted for, 8 oxygen atoms, and 5 plus 3 of 8 oxygen. 5 plus 3 8 oxygen atoms. Here 8 oxygen atoms, here 8, 2, 4, 4, 8, 6 hydrogen, and balance. So this is trial and error method of the balance. I have done it deliberately in this manner so that you can understand how to balance by trial and error. I could have written the correct one first. So P2O5 water, phosphate in water give phosphorus. Similar ones are others also. SO3 is there. Sulfur trioxide. Sulfur trioxide. Sulfur trioxide. SO3. TRI trioxide. And water is supposed to give H2SO4. This is sulfuric acid. Sulfuric acid. Sulfur trioxide in water gives sulfuric acid. Another one is you may ask this question to why not NO2? I ask you. Why not nitrogen dioxide dissolved? Nitrogen dioxide also dissolves in water. Only thing is it produces a mixture of two acids, HNO2 and HNO3. A mixture of two acids, HNO2 and HNO3. This is called nitrous acid. This is nitrous acid, and this is nitric acid. Both acids are there, nitrous and nitric. And therefore, this NO2 is often referred to as a mixed anhydride. NO2 is a mixed anhydride of both nitrous and nitric acids. A mixed anhydride of both nitrous and nitric acids. So these are the methods by which acids are prepared. That is by reacting the acidic anhydride with water. Reacting the acidic anhydride with water. To recapitulate, I go once again through that. First one, carbon dioxide. Water produces carbonic acid. It's a weak acid, H2CO3. Sulfur dioxide reacts with water, produces sulfurous acid, H2SO3. Nitrogen pentoxide reacts with water, produces nitric acid. Phosphorus pentoxide reacts with water, producing phosphoric acid. Sulfur dioxide and water react producing sulfuric acid. Nitrogen dioxide and water react producing a mixture of nitrous and nitric acids. So, nitrogen dioxide is called a mixed anhydride, a mixed acid anhydride. So, this is the method by which acids are prepared. All these acids, you must notice one thing: H2CO3, H2SO3, HNO3, H3PO4, H2SO4, SNO2. All these contain one element commonly. What is that? One element which is common is oxygen. In all these elements, in all these acids, you find there is oxygen. So they are oxyacids. They are oxyacids. First one I told you was they are producing hydroacids, and these are oxyacids. All oxyacids only can be prepared in this way. Oxyacids can be prepared in this way. So I have told you two methods today of preparing acids. Various methods of preparing acids are there. We will go to the third method after this. Hope it's clear to you. Any doubts, you can text me. I will answer you later. Now, next method of preparing acid. We have different methods as I told you. Two of them we have done. First one by dissolving acidic oxide in water. Second by direct combination with elements. Now third, method 3, that is by displacement method. Displacement method. The third method is called displacement method. Here, a less volatile acid can be displaced by a more volatile acid. I'm sorry, the other way. A more volatile acid can be displaced by a less volatile acid from its source. From which now, what is the volatile term? What do you mean by volatile? Volatile means what that vaporizes very fast. What that vaporizes very fast is volatile. Most acids vaporize by 100 degrees centigrade, mostly, and below that. There's only one acid, sulfuric acid, which is not volatile. Sulfuric acid. It is not volatile means its boiling point is very high. Its boiling point is 338 degrees centigrade. Very high boiling point. 338 degrees centigrade. All other acids you find, the boiling points are much lower. Much, much lower. So all other acids almost can be displaced by sulfuric acid from their salts. Their salts, other acids. Other acids, what are other acids and salts? For example, hydrochloric acid. Its salt is sodium chloride, potassium chloride, calcium chloride, magnesium chloride. These are all salts of hydrochloric acid. So from those salts, sulfuric acid can displace that acid. Now sodium chloride, the acid from which it came was hydrochloric acid. So sulfuric acid, if you add to sodium chloride, that hydrogen chloride will be sent out, displaced. It's not a displacement. In displacement, the reaction is usually a compound AB and a compound CD. When they combine, there is an exchange of partners. There is an exchange of partners. A takes D and B takes D, C. So AD and BC. It's an exchange of partners. AD and BC. Or CD. It's better to say CD. AD plus CD. This type of chemical reaction is usually known as displacement reaction. So, less volatile acid, less volatile acid, less volatile acid displaces a more volatile acid, from its salt. Now, less volatile acid we are taking in all cases sulfuric acid because its boiling point is very high. Now, more volatile acids, most other acids are more volatile. For example, hydrochloric acid, nitric acid, carbonic acid, acetic acid, oxalic acid, all other acids, they are more volatile than sulfuric acid. So, sulfuric acid is a less volatile acid. It can send out a more volatile acid from its salt. You take, for example, hydrogen chloride is a more volatile acid. Its salt is sodium chloride or potassium chloride or any other chloride. It is a salt. Salt of hydrogen chloride, sodium chloride. Suppose you add sulfuric acid to it and warm up, heat it up. H2SO4 is added to sodium chloride, heated. What will happen? This decomposition, displacement will take place here. Actually, the reaction is not called displacement reaction. It is called double decomposition reaction. But there is a displacement of the acid, so it stays between. That's all. Now, sodium chloride, this sodium, this combines with this salt, and hydrogen combines with this salt. The first reaction in this will be. What's the first reaction? Sodium sulfate. Actual reaction takes place in two stages. I told you already earlier, sulfuric acid is a dibasic acid. So such reactions take place in two stages. In one stage, one hydrogen atom will go out of it, The second stage, second I will also go over it. So in this case, it will be first NaHSO4, NaHSO4 plus HCl. Now our interest is HCl. We want HCl. We want an acid. That's HCl. The other compound which is formed is sodium bisulfate. This is called sodium bisulfate. Bisulfate. Sodium bisulfate. And this is hydrochloric acid or hydrogen chloride. You know, when hydrogen chloride is dissolved in water, you get hydrochloric acid. Hydrogen chloride, this is a gas. Hydrogen chloride. So you see here a less volatile acid. Now I take it like that. Less LVA stands for less volatile. Less volatile acid displaces a more volatile acid from its salt. This is the salt of hydrochloric acid. Hydrochloric acid is salt in NaCl. So from NaCl, sulfuric acid is able to displace hydrochloric acid. The reaction is used for preparing acids. In fact, hydrochloric acid is prepared this way. In the laboratory, if you want to prepare hydrochloric acid, this is a method we have. In manufacturing, in industrial process, things are different. But in the laboratory, if you want some hydrochloric acid to be prepared, this is the method we use. The other day when I told you about acids, I told you the reaction takes place in two stages because the sodium bisulfate is also having some hydrogen and therefore it behaves like an acid. Though a salt, it will behave like an acid. NaHSO4 NaHSO4 will combine with another quantity of NaCl. NaCl plus NaHSO4. NaHSO4 can act as an acid as there is hydrogen. Will give Na2SO4 plus HCl. So some more HCl comes out in the second reaction. Really speaking, both these reactions take place at the same time. Both these reactions take place at the same time and lot of hydrogen chloride prepared. Normally, we combine these two equations and say the final reaction is here there are two NaCls. So we write 2 NaCl. Excuse me. 2 NaCl plus the NaHSO4 is here, NaHSO4 both sides are there. So in the equation, if both sides there is the same quantity, that can be removed. So this comes here actually. So this can be cancelled. So NaCl plus H2SO4 gives Na2SO4 plus 2HCl. 2HCl, you can see. 2HCl. NaHSO4 cancels. NaHSO4, Na2SO4 plus 2HCl. This is the final reaction. Please note down in your notebook. All this will be noted down. A less volatile acid displaces a more volatile acid from its salt. NaCl, it is a salt of a more volatile acid. H2SO4, less volatile acid. Reaction takes place in two stages. The final rate, you should write down all these three equations. 2 NaCl plus H2SO4 giving 2 Na2SO4 and 2 HCl. I hope it's clear to you. This is actually this reaction is known as double decomposition. It is known as double decomposition. But for our purpose, we call it displacement, that's all. Our purpose is to show that the acid is displaced from its salt. That's why I wrote displacement method. Otherwise, this reaction is actually AD plus CD. AD plus CD, the reaction is actually double decomposition. I hope it's clear to you. I hope it's clear to you. A less volatile acid displaces a more volatile acid from its salt. Sulfuric acid is a less volatile acid. It displaces the more volatile acid, hydrochloric acid, from its salt and HCl. Okay? So this is another method of preparing acids. Another method of preparing acids. Can I remove it from the board? Okay. I hope you're taking it down. There's one more method of preparing acids. We have to study the fourth method. One more method we have to study, the fourth method. There are certain elements like say sulfur. Certain elements, sulfur or phosphorus, P. These elements, when oxidized, try to understand. If I oxidize sulfur, what will happen? What will be the product? Oxidized means you add oxygen. Make it combine with oxygen. Sulfur combined with oxygen, what does it produce? What of you will say that this is sulfur dioxide. Sulfur dioxide. And further oxidation takes place, it will give sulfur trioxide. So sulfur dioxide or sulfur trioxide will be formed from sulfur when it is oxidized. And you know when those two are reacted with water, you get acids. So if sulfur is made to react with something which can give oxygen and change it into sulfur dioxide or sulfur trioxide, think about it. Sulfur is treated with something which will change it into sulfur dioxide or sulfur dioxide, and that is water will give the acid. So this thing which supplies that oxygen to sulfur, what is this substance which supplies oxygen to another substance called? A substance which supplies oxygen to another substance is usually called an oxidizing agent. Oxidizing agent. Oxidizing agent. A substance that supplies oxygen to another substance for oxidation is called an oxidizing agent. So sulfur needs an oxidizing agent. The oxidizing agent normally used for this purpose is another acid which is a very good oxidizing agent. It is HNO3 nitric acid. Nitric acid. So sulfur, when boiled with nitric acid or heated with nitric acid, sulfur or is a yellow powder or yellow block sulfur. That yellow powder of sulfur is boiled or heated with HNO3 nitric acid. Sulfur will get oxidized with nitric acid. Nitric acid is an oxidizing agent, very powerful oxidizing agent. It oxidizes sulfur. The result of this oxidation will be sulfur and nitric acid. It will produce sulfuric acid. One substance which will be produced by it is sulfuric acid. And it itself gets reduced to NO2, nitrogen dioxide, and finally water. H2SO4 plus NO2 and H2O are the products. The equation can be balanced. You can get this equation balanced easily. Try to do it yourself. It's a good thing to make an effort and balancing yourself. Sulfur with it is any difficult equation to balance 6 SNO3, 6 nitric acid molecule, 6 SNO3, producing H2SO4, H2SO4 plus 6H. What H2 is taken here? So next should be 2H2O. 2H2O plus another H2 will be 3H2, 6H. 6H is made like this. 2 here and 4 here. If 6HNO3 comes, then it is 6NO2. 6NO2. And you require the hydrogen is balanced. Similarly, nitrogen is balanced. Sulfuric acid is all are balanced in this case. So check out. S plus 6HNO3, H2SO4, H2SO4. Oxygen total is 18 atoms of oxygen, 4 here, 12 here, 12 plus 4, 16, and 4 here, correct. Here 4, 12, so 16 and 2, 18. So all the oxygen atoms are also balanced, you can see. Such equations you should learn how to balance is necessary. So an oxidizing agent can easily oxidize sulfur to sulfuric acid. This is sulfuric acid. This is a method of preparing sulfuric acid. Oxidation of sulfur by nitric acid. This is not displacement. Nitric acid. Oxidation. So also phosphorus can be oxidized. P plus HNO3 nitric acid will give the acid of phosphorus is H3PO4, phosphoric acid. Phosphoric acid. Phosphoric acid. H3PO4, that is the acid. And of course, nitrogen dioxide will be coming out and water will be produced. Reaction. I leave it to you for balancing. It's an interesting case for balancing. Once you have done the first one, sulfur, this should not be very difficult. I put phosphorus as P. Normally, phosphorus is put as P4. It will make it more complicated, which I want to avoid. So I'm using P as phosphorus atom. P plus HNO3, giving H3PO4 plus NO2 plus H2. This I will read today to you as an assignment. Today's one assignment is this: balance the equation P plus HNO3 giving H3PO4 NO2 plus H2. I want you to do the balancing part. You fail, try again. That's all I can say. You fail, try again. So we have done all 4 methods of preparing acids. The 4 methods are: number 1, direct combination of the elements hydrogen with another non-metal. First one, example, S sulfur plus oxygen sulfur dioxide dissolved in water, sulfurous acid. That's one. Second one, second method I told you was what was the second method? By dissolving the acidic oxide or the acid anhydride in water. Reacting this, not actually dissolving, it's reacting. Reacting the acidic oxide with acid, with the water. Acidic oxide with water will give you acid. Examples: CO2 plus H2O, H2CO3, SO3 plus H2SO4, sulfuric acid. Similarly, N2O5, hydrogen pentoxide and water, nitric acid. So acidic oxide dissolved in water, giving acid. Second. Third method was by actually double decomposition, or we consider displacement here. That is displacement of one more volatile acid by a less volatile acid from the salt to the more volatile acid. Salt to the more volatile acid plus a less volatile acid will give another salt and and acid. That's the third method. And the fourth method, elements like sulfur and phosphorus, even carbon can be oxidized, so on the same lithium lines. So elements like sulfur and phosphorus oxidized by nitric acid. SNO3 is nitric acid. SNO3 is nitric acid. We treat phosphorus with concentrated nitric acid, sulfur with concentrated nitric acid. When the element gets oxidized to the acid directly and releases the oxides of those elements. So these are the four methods of preparing acids. I hope you understood preparation of acids. After this, we will pass on. After this, we will pass on. Please, you have noted down. If you have not noted down, please do that again. I give you time. I'm giving you time. Please note down. Very important reactions. Often these come in the examination also. Okay. The next is the properties of acids. We will be doing in the next class. Properties of acids. There are several properties of acids we have studied. Today we have done only preparation of acids. Let us close down today with preparation of acids. All right. All the best to you, children. I hope you understood today's topic. We'll continue with the properties of acids in the next class. Until then, take care of yourself. Take good care of yourself. All the best. Bye.